Morning Year 10. Here we are again. Second week of this 5-week stint on which we're hoping to run through some new topics ready for the Maths GCSE next year. This is what we're running through, all the green stuff on here. I'll take you a copy of this. Last week we had a look at understanding gradients of parallel and perpendicular lines. This week we're going to be working on non-linear nth term rules by using a diagram to help, or suitable method for quadratic sequences, and solving inequalities in the same way as solving equations, blah blah blah. Those are the two that we're going to be doing this week. Should say the one we're actually doing here is the suitable method for quadratic sequences. I'm not actually going to be showing you any nth term rule diagrams at the moment, but we'll come back to those at some point. If you have the suitable method for quadratic sequences, you can basically answer any question to do with it. So I'm going to run through how to do it. I've got a feeling I have done this with you before. Vaguely remember doing this with you. It's not on the numeracy exam, so I've probably left it to one side for a little bit. But I'm just going to run over it again from scratch so you know how it all works. So this is what we're doing, finding nth term rule of a quadratic sequence. If you want to get some paper and copy this down, pausing as you go so you can keep up with me, then that might be a good thing to do. But anyway, you're going to be answering the sheet which is attached to the lesson, which I've got a copy of it here, hang on, is this sheet here. Okay, quadratic sequences. I'm not necessarily expecting you to do all of these. That would take way too much time. So you're probably going to be doing a few, maybe 3 bronzes, 3 silvers and 3 golds, depending on how fast you are at doing this. You know, I don't want you to spend more than an hour or so on this, and that would be absolutely fine. What I'm going to do is I'm going to do these 3 questions here as my examples, so that you can see how it works for something like that, where you just got to find the next term, something like that, where you've got to find the nth term rule. It's a little bit easier than this one. I know they look similar, but there's things about this one that make it a little bit harder. But I'll run through all that now. So I'm doing the question 8, and then you're doing whatever you can fit in the time that you have available to you. I've also attached the answers to all these as well, so you can check your own work. All I ask you to do really is to turn in the work. If you can put a photo of your actual work, that's great, even better. It's just nice for me to see that you're actually doing it. It looks from the Hegarty feedback and the fact that most of you turned it in, that you all did the work from last week on parallel and perpendicular lines, so thank you for that. Right, let's go. So, finding nth term rule of a quadratic sequence. Right, well, a couple of things. What is a quadratic sequence and what is an nth term rule? Well, I'm just going to give you an example of an nth term rule that is a quadratic sequence and show you what it actually means. So for example, if I had the following rule, n squared plus 3n minus 4, then that could be the nth term rule for a quadratic sequence. A quadratic sequence is one which has an n squared term in it. It doesn't have an n cubed term or anything fancy like a square root, just an n squared term. Might have an n term as well, might have a number as well. I mean, n squared is a quadratic sequence. It's the square numbers, 1, 4, 9, 16, 25, 36. That's the simplest quadratic sequence you could possibly have. But if we introduce a linear element to it and a constant, it's still called a quadratic sequence. So that's the nth term rule of a quadratic sequence. What's a quadratic sequence? Well, it's a list of numbers that are related by a rule. I just read one out to you, 1, 4, 9, 16, 25, 36. That is a sequence. It's a quadratic sequence. This is also a quadratic sequence. And if we want to see what the sequence is, we literally have to put into here, in turn, the numbers 1, 2, 3, 4, 5, and see what comes out. Where's my calculator? Bear with me. Right, so I'm back up with my calculator, okay, just to show you what the values in this. I could work them out in my head, but I'm being really lazy here. So if I go into table mode in my calculator, which is number 9 on mine. It'll be different on yours. And just like you do with trial and improvement, I'm just going to type in what f of x is. And I use x's rather than n's, but that went well. I'm effectively typing in what you can see in front of you there. So x squared plus 3x minus 4, like so. Might get a g of x, which I'm just going to ignore. And I'll just do 1 to 5, the first 5 numbers in the sequence. And here they are. So when n is 1, the answer is 0. When n is 2, the answer is 6, 14, 24, and 36. Let me just write those. Whoops. Let me write those down on my piece of paper. So we've got 0, 6, 14, 24, and 36. So, and there will be some more terms after that. So those are the first 5 terms of this quadratic sequence. And you can work them out without a calculator just by subbing in turn 1 into there, that'll give you 0, 2 into there, I'll give you 6, 3 into there, I'll give you 14, etc. I'm sure you could all manage to do that for yourselves. Okay, I'll just check one of them to make sure it's right. So putting 3 in should give me 14. Let's just check. 3 squared is 9. 3 times 3 is also 9. So 9 plus 9 is 18. Take away 4 is 14. Bingo, it works. Okay, so let me now take you through the 3 questions from the sheet, the question 8s from the sheet. So these are your examples. Okay, and I'm going to start with question 8, bronze. In question, I don't know why I did a capital N there, very weird. For bronze, the numbers were 6, 6, 10, 18, and 30. And the question was, what number comes next? Okay, so to do this, what you do is you write the numbers out, leaving a gap between them, like so. And then you work out what the difference of the gap is. So 0, 4, 8, 12. Well, those are the gaps. You then do the gap of gaps. Now, if it is a quadratic sequence, you'll know it's a quadratic sequence because when you get to this line here, they will all be the same. So notice they're all the same value. That is your clue that you're looking at a quadratic sequence if you weren't sure. Then to find the next number, which is here, it's a bit like a pattern. You basically carry the pattern on. So I'd want a 4 there, which would lead to a 16 there, which would lead to a 46 there, like so. All right, so the answer is 46. Okay, so that's how you find the next term in a quadratic sequence. And I could keep going. I could get the next one after that just by basically putting a 4 there, a 20 there, and then going 66, etc. And I could keep going forever like that. So that's how you find the next term or the next term after that. Not particularly useful though if you want to say find the 50th term, because you're not going to write that out all the way across to the 50th term. So we actually need a way of finding the formula for something like that, what this thing here, the nth term rule as it's called. So I shall now do the question 8 silver and do exactly that. So for question 8 silver, the numbers are 5, 10, 17, 26, and 37. I'll put dots on these to indicate that they actually continue. So, excuse me. Once again, I'm going to write out the sequence, leaving sort of a gap between them, like so. And just like on the previous example, it starts the same way as this. I fill in the gaps. 5, 7, 9, 11, like so. So I fill in the gaps, and then I fill in the gap of the gaps, and hopefully they're all the same. And indeed they are. They're all 2 this time. Just move my piece of paper up a bit so you can see. There we are. So they're all 2 this time. So how do you find the nth term rule? Well, this is what you do. Okay, you have to try and remember this because it's a little bit complicated. You start by looking at this number here, this one here, and you half it. Which is obviously 1. And then what you do, for reasons which we're not going to explain now, that tells you that the n squared part of the rule is 1n squared. So if you go back to the previous one here, although I didn't work out the nth term rule for this, I would know, because it's a 4 here, I would know that the first part of the rule is 2n squared. Okay, it would be that halved, 2n squared. So this one is 1n squared. Okay, so I now know that part of the rule, not the whole rule, is n squared, or 1n squared. I'm just going to call it n squared from now on. So what I do, and this is the clever bit now, is I write out the original numbers again. I shall do it here. So those are the original numbers. I then immediately underneath write out the numbers for the sequence n squared, the first 5 numbers in the sequence n squared. Well, I've already mentioned those earlier. N squared is the sequence 1, 5, 9, 16, 25, like that. Okay, so it's nice and simple. Of course, if it had been 2n squared, like in that example, I would have been writing out 2, 8, 18, 32, 50, or whatever n squared it is. Then, I like to draw a line like so, and to subtract these values from these values here. So we get 4, 6, 8, 10, 12. So I get a new set of numbers here. And this is how this works. I know from this work that the nth term rule for this contains, as its first part of it, 1n squared. So if I take that off the original numbers, what remains is the other bit of the rule, the bit that goes here, that finishes it off and makes it all work properly. I know it's n squared, but then there's some more to it to make these numbers here. And here's the thing. These numbers here will be part of a linear sequence. That's a sequence that only has an n and a number. And finding a linear sequence is something you should already know how to do. And you should be able to do them largely in your head. A linear sequence is found by looking at the gap in these numbers. I'll write them in, which is 2. And that tells you that this sequence here, 4, 6, 8, 9, 10, 12, is based on the 2 times table, because it goes up 2 each time. So it's 2n. Okay, that's the 2 times table, 2, 4, 6, 8, 10. But then you look at the first number, and it isn't a 2, it's a 4. So you have to add a little bit extra on to get the first number in the sequence. In this case, I'd have to add 2. Okay, so to get that number there, you look at the 2 there, and you look at the first number, and you think, oh, I'm not quite got the right start number. So 2n plus 2 is this sequence here. Okay, if you're struggling with linear nth term rule sequences, I'm sure if you look on Hegarty Maths, you can find a video on it, or just message me if you don't understand what I've done to get 2n plus 2 here. I know we've covered that before, so hopefully you know how to do it. And that's it. That and that make up the rule. So I'll just write it out here. The final answer then is n squared plus 2n plus 2. Done. Okay, so on to the gold. I hope you're still with me. That's 14 minutes now. On to the gold question. I'll just quickly do this one. I won't chatter so much. I'll just get on and do it. In fact, I'll stop talking altogether, and you can just watch me do this. Like we used to do those silent kind of things at the start of the year. I just sort of like wouldn't talk to you and show you something on the board. Perhaps I'll do this for the gold. I don't need to explain anything because there isn't actually anything new about this compared to the last one. Although it's a supposedly harder question, it's only harder because I think the numbers involved get a little bit trickier. But let's just do it and see. So I won't say anything. I will do this one and I will set it out in exactly the same way as I set this one out here. So here we go. I'm going to stop talking now. You can just watch. How's that? Done. That is how you find the nth term rule for a quadratic sequence. You've watched this video. If you watched it all, it's at 17 minutes. So you've got up to another 43 minutes to do as much as you can from the sheet. Mark your own work, please, and then just turn it in and let me know. You send a photo, that's brilliant. Okay, it's optional that, but it'd be great if some of you could. So that gives me peace of mind that you're all working properly. Thank you, everybody, for listening. Have a great day.